Welcome. Today we're going to be going over the test review. Now, yesterday I put up a video that was assignment number 11, and the page said 12, but it's still a good video review as far as how to do half angles and double angles. Now, this one combines them all. You have some difference in double angles. So let's go ahead and get started. It says right here, use information given about the angles alpha and beta to find the exact value of sine alpha minus beta, cosine alpha plus beta, tangent alpha minus beta. Now, first thing we got to do is get started is that these are properties require us to actually find out all three values. So like with this one, I'm missing tan alpha, and I'm also missing cosine alpha. So this is opposite over adjacent. This is adjacent over hypotenuse. And what I am given, I'm given sine. Sine has been given to me as, in this case, alpha is opposite over hypotenuse, which means that in this I'm given 12 over 13, which means that I have opposite and hypotenuse. Automatically, I could say that this is 12, and automatically I could say that this is 13. What I'm missing is the adjacent part of this. So with that, in order for me to find the adjacent part, I have to use the triangle is basically the unit circle, because I'm going to draw the unit circle now. And I'm going to find where pi is at. Pi is right here. This is pi. And I'm also going to find pi divided by 2, which is here. Which means that my angle, I'm going to be focusing on this quadrant right here in order for me to go ahead and get an answer. This is where my quadrant's at. Now, one thing to keep in mind, this quadrant is positive in the cosine. Well, actually, no, the other way around. Negative with the cosine, positive with the sine. So x is going to be, so when I draw my triangle with this one, okay, this part is going to be positive, this part right here is going to be negative. And the reason why that's important is because I'm given opposite, so 12, 13. When I find out my answer, the answer here, whatever it's going to be, needs to be in negative. Okay, what I mean is negative. Negative as far as the value. So let's go ahead and actually find out what that answer is. And I'm going to do that by applying Pythagorean theorem. So I'm going to go ahead and actually write down leg squared plus leg squared is equal to hypotenuse squared. I'll get 144 plus b squared is equal to 169. So I'll track 144 to both sides. I'll end up getting that this crosses out. I'll get b squared is equal to 25. And I want to take the square root of that. I find out that b is actually equal to 5. So that means that in this case, my adjacent side, well, one thing I did left out, I wanted to make sure that was important. This is plus or minus. We said that that side is negative, so that's going to be a negative 5 that goes here. This is going to be, without a doubt, negative 5. The reason why that's so important is that when we fill these in, negative 5, negative 5. So I have my three values, here, here, and here. Three values are done. Now, I have to now do the same thing with the tangent beta. So I'm going to go ahead and kind of draw a line to separate both. I'll switch colors to really define what is it that we're doing. Because see, the thing is that we have tangent beta is opposite over adjacent. And in this case, you'll have, one of these is going to be negative. Don't know which one yet. But I also have to find sine beta, which is opposite over hypotenuse. I already have opposite side. In this case, it's going to be negative 1. And I'll show you why it's negative 1. I don't know what hypotenuse is at, and I do have cosine beta. Cosine beta is adjacent over hypotenuse. And in this case, I have adjacent, which is 2. It's going to be positive, though. What I'm missing is a hypotenuse on this one. Now, let me draw the triangle so y'all get a clear idea. How is it that I figure out this is negative 1? When we draw the triangle, and we identify 3 pi divided by 2 being at this side of the unit circle, and the 2 pi is here, we find that our measure of focus is going to be here. So a quadrant. Okay, once we establish the quadrant, we go back and establish our angle. This is how I identify, because remember, we have an opposite over adjacent. This side, this triangle, we have positive, negative, which means that this right here is a positive 2, This is a negative 1. And that's how I was able to achieve a distinguishing where the negative belong. Now, what I still need to do is find out what the hypotenuse is. So for that, I'm going to use Pythagorean theorem. 2 squared plus negative 1 squared is equal to c squared. This being c in this case. I'll get 4 plus 5. Oops, not 4 plus 5. 4 plus 1. I jumped ahead myself because I'm already adding in my brain. C squared, and I end up getting 5 is equal to c squared. Now this is important because we find out what the hypotenuse is, which is a square root of 5. Now it's going to be positive because all hypotenuse are always positive. So square root of 5. So it means that this is square root of 5 and this is square root of 5. Now one thing I must do with this is rationalize it. Can't leave a square root as a denominator. So in order to do that, I'm going to do square root of 5, square root of 5. Same thing here, square root of 5, square root of 5. Let me erase this because I need space. Erase a little too much. Go ahead and try that again. Be a little bit more careful. And in this case, let's go ahead and actually finish the rationalization of this. All right, now this is going to be 2 square root of 5 over 5. Square roots cancel out. Same thing happens here, except that this becomes negative square root of 5 over 5. Okay, so I got my 3 values. Actually, let me undo that. I want to make sure that I encompass the negative that's there. Negative here and this. Okay, now I'm actually able to now apply all 3 of my different identities here. First one being sine alpha minus beta. You bring out your green sheet and you look for the identity that is in reference to that. So sine alpha minus beta is going to be sine alpha times cosine beta minus cosine alpha times sine beta. All right, so let's go ahead and fill in some values that we need. Sine alpha, it's right over there, 12 over 13. That's actually what's given to us. Cosine beta, 2 square root of 5 over 13 over 5. So let me go ahead and fix that. So 5 minus cosine alpha. Cosine alpha is negative 5 over 13. And sine beta. Sine beta is negative square root of 5 over 5. Okay, now let's go ahead and simplify this. What I mean is that when you're dealing with this, with 2 fractions, okay, now first of all, y'all see the 2 negatives over here on the right side? Those are become both positives. When you deal with fractions, you can multiply across. So I'm going to multiply those 2. 24 square root of 5. And I'll multiply those 2. It's going to become 65. That's going to be subtracted by 5 times the square root of 5, which is 5 square root of 5 over 65. Now with this one, they have a common denominator, which means that I could go ahead and add them both. And one thing in particular with this one, let me highlight it. If you have these terms the same, the radicals, if they're the same, you're able to combine them. It is unique in this case, so we're able to do that, but this becomes 19 square root of 5 over 65 as your answer. So with this one, A is going to be that answer. 19 square root of 5 over 65. Can't be reduced anymore. Now I'm going to extend the page, and I'm going to do the answers right below this, because the next thing we're going to do is now, let's see, we're going to do cosine alpha plus beta. So let's extend the page again. Cosine alpha plus beta. I pull out my green sheet, identify the identity, and I find out that my identity is cosine alpha, cosine beta, minus minus sine alpha, sine beta. Okay, great. Let's go ahead and find out what these values are. Let's see. Cosine alpha was negative 5 times 13. Cosine beta was 2 square root of 5 over 5. minus sine alpha. I think that was the 12, 13 that we originally were given. Yeah. And sine beta. Sine beta being negative square root of 5 over 5. Okay, good. Let's go ahead and apply this as well. Remember, as far as this part right here, these multiply. It's going to give me negative 10 square root of 5, and 13 times 5, again, is 65. Minus, in this case, I'm going to do 12 times square root of 5, which is negative 12 square root of 5, and 65 is the denominator again for multiplying 13 and 5. Now these two negatives make a positive. And again, the same thing approaches in this one, or same thing occurs when we have the same radical, same denominator, which means that we could go ahead and just add them together. So 65 we'll have there. It's going to become 2 square root of 5. So that's my answer for that one. Okay, very last one I have to do now is C. C is asking me for tangent alpha minus beta. So tangent alpha minus beta. So I'm going to look at tangent alpha minus beta, and I'm going to bring out the identity property by looking at the green sheet again. In this case, it's tangent alpha minus, write that down like this, tangent beta divided by 1 plus tangent alpha times tan beta. Okay, lovely. So let's go ahead and find out where my tan alpha and beta were. I think the first one was given. Oh, it's hurting the eyes. Okay, negative 1/2. So tangent beta is negative 1/2. So I'm going to go ahead and start filling some of this in. This is going to be minus negative 1/2. And I'm going to have 1 plus negative 1/2. What I'm missing so far is, what is this? The tan alpha. My tan alpha was 12 divided by negative 5. So 12 divided by 1, 5, 12 divided by, I'll just put the negative somewhere in there. All right, so what must we do in this one? Well, two things. We first have to get the numerators to become one fraction. These are both positive. And I'm going to do that by multiplying top and bottom by 2, like this, 2 over 2. And on this side, 5 over 5. The reason why I want that to happen is because as a numerator, I'll get negative 24 over 10 plus 5 over 10. Okay. And now I have an actual common denominator, and I could go ahead and add those together. So I'll do that in the next step. So I want to go ahead and also do this over here. Now this over here, these two negatives are going to become positive, and they're going to multiply across. So 12 times 1, 12, 5 times 2, 10. Okay, let's go ahead and make this a bit prettier. As a numerator, you could just add them. This is going to become negative 19 over 10 when I go ahead and combine these two numerators. Now on this side over here, I'm going to have to get a common denominator, so I will multiply this by top and bottom by 10. Or virtually, this is the same thing as 10 divided by 10. So the reason why I make it into that is because, and the reason why that is that this is really the fraction. You can multiply 10 on top, 10 on bottom. So, but the reason why I need that is because I want to get a common denominator there, because I want to achieve this, 22 over 10. Now, from here, I'm going to go ahead and apply, I'm going to multiply the numerator by the reciprocal of the denominator, because that's what happens. And these cancel out, and I'm left with negative 19 over 22 as the answer. So because of that, then that means this is negative 19 over 22. And my B, which I had here, was 2 square root of 5 over 65. So there goes ahead, and we solved problem 1 of the review. Let's go ahead and continue, and now look at the next problem. Next problem, next page. Okay, here we go. Now we're going to be dealing with half angles, double angles, double angles and half angles. I just said both. Now, in this case, we the biggest thing you need to do in order to achieve, to get the answer to this, assignment 11 covered this heavily, and where you have to also find out what is cosine theta, which in this case is going to be adjacent over hypotenuse. You have to figure out what tan theta is too. In this case, it's opposite over adjacent. What have you been given so far? You've been given sine theta, which is equal to opposite over hypotenuse, and you know that this is 7 over 13, which means that opposite already is 7, hypotenuse already know is 13, what is unknown is the adjacent. And for that, we're going to use this part of the information to draw a unit circle and come up with the actual hypotenuse with the correct side. Now this is going to be pi divided by 2, which is here, and then pi, so which means that this lies in this quadrant. Now there is something important we got to keep in mind, that when you draw this, okay, this is going to be 7, this is going to be 13. Whatever value goes in here needs to be a negative. Okay, so let's go ahead and find out what goes there. Leg squared plus leg squared is equal to hypotenuse squared. 49 plus b squared is equal to 169. We subtract 49 on both sides. Getting to find out we have a b squared equal to, in this case, oh, we get 0, 120. So we're going to take the square root of 120. Now, when I take the square root of 120, a couple of things are going to happen right here. I could actually take the square, first of all, this is plus or minus, so it's going to be minus. But the square root of 120 could be broken up into different parts. What do I mean specifically? Okay, if I go ahead, I could go ahead and say this is 10 times 12. Well, not 10. Actually, I could say that, but 10 is actually what I was not looking for. I'm looking for this. I'm looking into saying, okay, we have 4 times 30. Okay, and the reason why I'm bringing that the way I am is because I'm going to simplify this a little bit more. The square root of 120 becomes then square root of 30, which means that you have negative 2 square root of 30. So, and the reason why that's important is because this is more of a reduced form of radical. Now, you're going to apply this, remember this is my adjacent side. I still need to apply that over here. So this is negative 2 square root of 30, negative 2 square root of 30. Now you need to ask yourself, can the square root of 30 be simplified even more? Well, you start looking at the factors. 30 has just 5 and 6, 2 and 15. So I really don't see 3 and 10. None of those can square root anymore. But for the tangent side, for this one, we do need to rationalize this. So we're going to multiply this by 2 square root of 30, 2 square root of 30. And this is what happens with this. As a numerator, 7 times, this is going to become 14 square root of 30. But as a denominator, you'll be left with negative 4 times 30, which means that this is really then 14 square root of 30 over 120. I'll put the negative, you can move the negative numerator or denominator in this case, but it needs to remain negative. Now 14 over 120 could actually be reduced. And if 14 over 120 could be reduced, we're actually going to put down then, I have my calculator right here. Let's find out what it is. But before I do that, just let me make sure I got the right pointer selection. 14 divided by 120. Math frac, 7 over 160. So 7 over 60. So which means that you can reduce this to negative 7 square root of 30 over 60. All right, and this is really what you're going to be looking at when you're applying this one. When you're applying tangent. I have cosine, and also I have sine. Okay, so now from there, all you really need to do is apply the angles, the double angle formulas, you have all three parts to be able to apply all four of these components. This one, this one, this one, and this one. If you want, I'll go ahead and do one of them for y'all. Let me do, like, let's say C. The reason I'm doing one is because I'm starting to run a little bit out of time here. So I'm going to just do C because I just wanted to practice probably one of the half angles, which is a little bit more of a, that's sine theta divided by 2. All right, so sine theta divided by 2 is going to be equal to plus or minus the square root of 1 minus cosine theta all over 2. All right, so let's go ahead and actually do this. Now, first of all, we need to think about how theta 2 applies into this quadrant right here. And to do that, I'm going to make this theta 2, but I need to do that, I need to divide everything by 2. So this really becomes 4, and pi divided by 4 is actually right over here, actually. So this becomes this quadrant right here. So if I get that quadrant right there, all that is positive, which means that this sine theta will be positive, nothing negative with it. Now, once I have that out of the way, I could go ahead now and apply. I have cosine theta. I found that out earlier. Cosine theta was negative 2 square root of 30 over 13. 2 square root of 30 over 13. Okay. Divided by 2. Now, I want to get rid of this 13. This is going to be my highlight of my focus I'm going to start from. So it means that I'm going to go ahead and multiply top by 13, bottom by 13, because what I'm going to do is distribute this 13. 13 is going to come here and cancel out that 13. So this is going to be my answer at the end. Let me erase some things here. The reason being is I want to make sure I have enough space. Okay. So let's go ahead and actually write down. I'm going to have the square root of 13. These two negatives make a positive. Plus 2 square root of 30 over 26. Okay, what do I do from here? I'll go ahead and break up the square root. So if you bear with me for a second, I'm actually going to write over these solutions because I don't want you to lose sight of what's there. Square root of 26. I can't keep that as a square root, so I'm going to multiply top and bottom by square root of 26. Which means I get square root of 13 plus 2 square root of 30. Now I'm going to put on here 20 square root of 20, actually just 26 like this. And the reason being is because I combine both of these. Just the way I was able to split them up, I also could put them back together. But what's going to happen is that this 26 are going to multiply to both of these. So your answer is actually going to be somewhat of a large, not a large number, but a little bit larger than you're used to. And let me tell you what it is. It's going to be, let's see, let's go back. So I could go ahead and do 13. Okay, it says right there, 13 times 26. That's the number I was trying to multiply. 13 times 26, 338. Which means that I'm going to have the square, oh, I'm right. Well, I don't want to write anymore. 338. 338 plus 52, which is 2 times 26, square root of 30. That's all that's correct. Over 26. So this will be the answer for C. And let me go ahead and shift over to the other problems just because I'm starting to run short on time. Let's look at the other problems. Now this one says use the half angle formulas to find the exact measurement. I think that's the last one on the review. Now what I want to do with this, I also did some of these on the assignment. I think that's it. Okay, so I'll deal with the harder one now. Let me give you the general premise on this. Okay, sine of theta divided by 2 is equal to the same thing as sine 1/2 times theta. Now, you might be wondering, why did you break it up? Why did you change the divided by 2 into a fraction? Reason being is that we have to do something similar to this. I have to take sine and take out a 1/2 from it. And I'm going to be left with my angle. So this is going to be 5 pi divided by 6. The reason why this is so important is that because my new theta, okay, this is a half, this is theta. That means that my theta, here, let me change color so I can make sure y'all, my new theta is 5 pi divided by 6. The reason why that is important is because when you apply your half angle formula, like in this case, sine theta divided by 2 is plus or minus square root of 1 minus cosine theta divided by 2. The very next step in solving this is to apply the theta. Square root of 1 cosine 5 pi divided by 6 divided by 2. And from here, 5 pi divided by 6 actually has a value for cosine. If you can bring out your unit circle, this is unit circle, you're going to be able to get the actual value for that. So I'm finding 5 pi divided by 6, which I did. It's going to be negative square root of 3 divided by 2. So in this case, it's going to be negative square root of 3 divided by 2 over 2. And then from here, these two negatives make a positive. You're able to solve. Again, you want to rewrite again. You want to go ahead and start by getting rid of this 2 by multiplying top and bottom by 2 inside that square root. Now from here, and then from there you're able to simplify just like the other ones. Now if you want additional practice, I did put Simon 11 up on video by accident. Now I do want to discuss this one because a lot of people are probably seeing the cosine and saying, Mr. Sandoval, what do I do if I'm approached with this kind of problem? One simple thing, change this to cosine. This is really 1 over cosine. Actually, not cosine. Cosecant, I think, is really just sine. Yes, it is. So it's not cosine. You can change it to sine. In terms of sine. This is sine 7 pi divided by 12. The reason why that's important, actually, I'm starting to notice that. They gave you, oh no, they didn't give you the same one. You can do something similar to break it up. It's going to be 1 sine 1/2 7 pi divided by 6. You apply your half angle formula, but is a denominator in this case. So this is going to be equal to 1 over square root plus or minus 1 minus cosine theta over 2. You might be saying, where do I do next? Remember, this is your theta because of the property I showed right above. So that means that in this case, this is going to become 1 over square root of 1 minus cosine of 7 pi divided by 6 over 2. Remember, this is when you look at your unit circle to get a value for cosine. So let's go ahead and identify the value for cosine. Value for cosine is going to be 7 pi divided by 6. Okay, value for cosine is going to be negative square root of 3 divided by 2. Which is actually a little interesting because I want to say that's what I got for this one over here. So I just want to make sure I looked at everything correctly. 5 pi divided by 6. Actually, it does. For both values, in that case, you're still dealing with the same value. Negative square root of 3 divided by 2. It's coincidence of angles. So that means in this case, you still have 1 over square root of 1 minus, well, not cosine, negative square root of 3 divided by 2 divided by 2. Now, again, you're going to do the same process for solving this. Now, if you want, I think I may have, actually, I'll have some time to finish this. Not a lot. Okay, first of all, these become positive. So let's see if I could get this done before time takes me away. 2 and 2. Okay. What's going to happen, this 2 is going to multiply with this, 2 is going to multiply here, but the 2's are going to cancel. That's the reason why I'm multiplying 2 top and bottom. because in essence, I'm now going to be able to write this down. Square root of 2, well, actually remember this is still all over 1, so do not forget that. 2 plus the square root of 3 over 4. Now I'm going to break up the square roots. So over 1, and I'm breaking up numerator and denominator. Square root of 4. This is going to make 1 over square root of 2 plus square root of 3 divided by 2. And then from here we apply numerator times the reciprocal. The denominator. 2 plus square root of 3. So what's going to happen with this one, 1 times 2 is going to become just 2. 2 square root of 2 plus square root of 3. I can't have that as a denominator, so I'm going to multiply this by 2 plus the square root of 3, and top by 2 plus the square root of 3. These squares are going to cancel out such that you end up with the next answer in this, 2 plus the square root of 3 all over 2 plus the square root of 3. Now at this stage you have to multiply by the conjugate. The reason why the conjugate is really just this part right here. This is known as a conjugate. When you have a binomial, you have the negative portion of it. The reason why is because once you do that, you're going to be able to cancel out the middle terms and just be left over with what you have left over. Now don't forget, these are foiling. So when you do this, you're actually going to end up with this as a numerator. And as a denominator, okay, 2 times 2 is 4. 2 times negative 3 is minus 2 square root of 3. 3 times s plus 2 square root of 3. And square root of 3 minus s minus 3. Square roots cancel on the last part. These are going to cancel out. The middle terms are going to cancel out. After that, 4 minus 3 is just 1. So these right here just make 1, which means that you're really just left with the numerator. 2 plus the square root of 3 times 2 minus square root of 3. After that, you really don't need to do much more. And this is your answer. Now, what I want y'all to do is go ahead and review this video. Remember, you have to be able to remember, understand, and apply. So what I suggest is go ahead and try to recreate each of these problems without looking at your solutions. And if you're able to do that, that means you've gained mastery of this. All right, well, thank you and good luck tomorrow.